One of the significant causes of erosion on any of these shorelines, and particularly this one, is where the runoff from upland areas comes onto either the buffer area or the upper marsh or the lower marsh. As the water travels longer and longer flow paths, it starts to concentrate and collects, and then it starts to gully. And especially on soft marsh sediments, those gullies can be dramatically deep and wide. And so what we did was we tried to do some regrading of the upland area in order to take runoff that normally would have run onto this marsh and move it laterally and put it into a stormwater green infrastructure system. So this bioretention system that was designed was a typical design. It's sized. Most people don't even know it's there. It can be mowed. It's very easy to maintain. And it was designed to not only accommodate the runoff, but how it works is the water filters through very permeable media, collects at the bottom where it can either infiltrate, or if the system fills up, it would just flow as it normally would right into the bay. We also tried to design in this system what we call wet feet, or we have basically a saturated layer of stone at the bottom, and what happens there is denitrification. So the Great Bay is impaired for nitrogen from all the various sources, and so anywhere we can actually start to remove nitrogen, it's just beneficial for the bay. As you see here, the typical erosion pattern we see in these marshes is that the marsh gets undercut. Once it gets undercut, then it's overhanging. The overhanging piece starts to slowly subside, as you're seeing over in the foreground here. Once it subsides, again, the vegetation is no longer viable, and then it starts to erode, or chunks of it will come off, and in the winter these can actually raft out with ice, and so now and then you'll see chunks of these out in the mud flats after the winter. So what we typically do to monitor the erosion is we'll drive in horizontal pieces of rebar 2 feet or 3 feet long. We'll put them in flush with the marsh, and then after a few weeks, months, or years, we'll come out and read how much is exposed. That would then give you the erosion rate, the amount of exposure divided by the time that you had in between readings. Just wanted to show you an erosion pin, and so here you can barely see the tip of the rebar sticking out. So this one was last checked or reset probably about 8 months ago, 6 months ago, probably around January or December. And it's only sticking out maybe an inch. So 6 months is half a year, so that would be an erosion rate of 2 inches per year. What typically happens, as we've identified before, is the bank gets undercut. And as you look eastward, you can see, again, this process where it gets undercut, it accelerates, the marsh starts to collapse, and ultimately the entire pieces of marsh just fall down to a lower elevation, and this is all washed away. And again, if you look at this scarp is on the order of 3 feet high. And if you're trying to protect the marsh, your options are, for example, come out with a gradual slope. And if you did that, you might have to have that slope go out 100 feet or more into the mudflat in order to have a gradual enough slope such that you don't get aggressive erosional attack on that vertical face. The other option is some type of armor, whether it be core logs with vegetation or a sill. But again, your biggest Achilles heel, or your biggest challenge is you can't grow anything that's really going to do erosion protection with roots below the elevation of mean sea level, which is about right here. So that's, again, why you need some type of reinforced sill in the leading edge. On the remaining portions of Wagon Hill Farm, instead of building out 20, 30 feet like we did before, we're only talking about building out a little, if any, putting in some type of structure that will hold the line on the erosion. But again, we have to start to create a better environment for the marsh grass, one, to be able to grow, so getting rid of shade, preventing foot traffic on it, but also the opportunity for the marsh to migrate landward.
Okay, another important potential cause of erosion is shade. So on top of overuse by people, just trampling of feet and paws, especially paws, because they have those sharp claws, they do cause a lot of erosion. We wanted to consider shade because there was there was 4 or 5 large shade trees that were being undercut, and their limbs were extending way over the marsh. And most people don't consider shade, but I want to show you this. This is one of the impacts of the shade from this oak tree. And you can see there's very few plants that can survive under it, and that's because these plants out here, these perennial halophytes, these perennial plants, perennial grasses that have adapted to living in salt marshes, and they're perennial, so they come back year after year. They can't survive here because they can't produce enough carbon resources to have all their adaptations and survive the winter. So you can see this little dieback zone. And so we had dieback zones much larger than this around the corner where the trees were shading the marsh. So here we have another section of shoreline which is comparable to the area that was eroding that we protected. And we can see all the blocks of peat in front here that have been falling off the top. You saw from the shot all the paw prints and the foot traffic and the shade from these oak trees is just preventing these plants from holding this peat together. The plants die, the peat falls apart from the actual activity of walking, but then in the winter it will also fall apart because ice will tear it apart too.